Today we're going to be learning how to name alcohols. Now, alcohols, like any organic compound, the ending is very important. Alcohol ends with OL. And in our little practice problem here, the ending is OL. And that's how, if you're reading the formula, you'll know it's an alcohol. Now, if you're looking at the line diagram, like here, you'll note that there is always an OH attached. And all alcohols have an OH attached. It's very important to note. So before I show you the general formula, I want to show you this example. So the naming is very similar. You always start by identifying the longest carbon chain. In this little example, it's 5. That's why I said pent. And you always have to state the location where the OH actually branches out of. So in this case, I've counted this direction, left to right instead of right to left, because then it has a lower number. So 1, 2 is the location. So I've said pent-an. Now, why did I say an? Well, just like it's a pentane. Now, how I know this is because it's only made up of single bonds. But say there was a double bond included, then I would have said en. Now, you may be thinking to yourself, where's the e? You didn't put pent-a-n-e. Well, that's because I'm not finished with my naming. You only put an E at the end if it's needed, and if you're finished with the entire formula name. So here I'm not done, so I'm not going to put an E because that shows it's over. The OL is the final ending. Now, you may be wondering, what is this big R's and C's and OH's? Well, that's the general formula of any alcohol. So, as you can see over here, with my little model, this is what an alcohol sort of looks like. This is the carbon, which has 4 valence electrons, which can bond to anything. 3 of them are just any molecule. In chemistry, you might see the letter R, and that's like in math, you use X or Y as a variable. In chemistry, you use R. And one of them will have to be an OH. Okay? Let's get into some practice problems. So, as always, we start the same way, counting the longest carbon chain. So let's try it. 1, 2, 3, 4, 5, 6 appears to be the longest, so I'm going to use the prefix hex. And there's 2 odd things about this organic compound. We have a double bond, making it an alkene, and we have a OH, making it an alcohol. So that means we have 2 things that we have to state the location of. So we should have 2 numbers in our final answer. But the question of the day is, which takes precedence over the other? Which is more important? Well, similar to how the double bond or triple bond is more important than a substituent is, a OH is more important than both the double bond and then the substituent. It's more important than anything. So we're going to give that the lower number. So if you look over here, I counted this direction before, but I'm going to count the other direction now. 1, 2, 3, 4, 5. So I'm going to give the OH carbon 2 rather than going the opposite direction. So this is the final name of the compound. Hex 5En. Note, I didn't put the E because I'm not done yet. 2OL. Okay. Let's try another, shall we? So, this is a silicate molecule, and I need the prefix cyclohexanol. I need to include cyclo to indicate it's in a circle. Now, the longest carbon chain, whenever you're doing a circle, it's really easy. It's just whatever makes up the circle. So 1, 2, 3, 4, 5, 6. So I'm going to put hex after I put my prefix here. That's very important. And then there's no double bonds or anything, so AN. Now you may be thinking to yourself, ha, she made a mistake. I forgot to include hex 1O. Well, I actually did this on purpose. The reason is because since it's in a circle and it's symmetrical, you can place the OH wherever you want, because when I turn it like this, it's still the same. When I turn it any which way, it's still the same. So I could place it on any of the carbons, and because it's a circle, they'd all look and molecularly be the same, just twisted a different way. So that was an easy one. Now let's get on to a more difficult alcohol. So, now we have two OHs attached. So, we start by counting the longest carbon chain, 1, 2, 3, 4, 5. So, pent, it's a pentane because there is no double bonds here. And I'm not going to include the E there because we're not done yet. Not quite yet. And just as if you have two substituents, just how, say the substituent is methyl, I would say dimethyl, and then before that I would have stated the location of the two. Now I'm going to say diol. So if you look over here, this is how it is actually spelt, diol. And if I had 3, I'd say triol. So, and I'm going to state the locations now. So 2, 3, because I want to give them the lowest possible numbers. And that is the final name of the compound. Oops. Now let's try some more difficult alcohols. So, as always, we count the longest carbon chain. 1, 2, 3, 4, 5. No, this is not a carbon, so it's 4. Now, I'm obviously going to count this direction, so 1, because we want the lowest carbon for the OH to branch out of. So the answer is butane 1-ol. Now, the special thing about this compound, and the reason I picked it, is to show you it's actually called a primary alcohol. Now, why is this? Well, let's look down here. So the OH takes up one of the carbon's bonds, and it's bonded to one other carbon. The carbon are the important. It's also bonded to 2 hydrogens, which we don't indicate because the carbons are what we care about, not the hydrogens. So because it's only bonded to one outside carbon, it's called a primary alcohol. Okay, let's get rid of this. Now let's look at this one. So this molecule is, again, the longest carbon chain is 1, 2, 3, 4. And this OH is bonded to carbon 2. I count it that way because it's lower than 3 if I count the other direction. Now, this one is butane 2-ol. And the special thing about this one is this is a secondary alcohol. Now, how do I know this? Well, let's look down here. So, we have the OH, which counts as one of its bonds. And we have 2 carbons bonded in addition out of this special carbon. This is the only one we really care about in order to identify whether it's secondary, tertiary, or primary. And the reason is because that's the one the OH is bonded to. And as you can see, it's bonded to two other carbons. So that's how we know it's secondary. 2 is secondary. Okay? There we go. And on to our last example. This one looks a little different, and you guessed it, it is tertiary. But let's see why. Well, first of all, can't get confused and forget about this little methyl substituent. So 1, 2, 3 is the longest carbon chain. So I'm going to use the prefix prop. It's also all single bonds, so you put AN, propane, but you don't include the E because we're not done yet. And you always start, again, with the substituent, then the longest carbon chain, then the single bonds or whatever, so the ending, so AN. And then you're going to talk about the OH, which is the most important part. So let's see if this is a tertiary molecule. So we have our special carbon here, carbon 2, because the reason it's special is because the OH is bonded to it. So we're going to pay attention to this guy. Now, over here, you can see that it's bonded to this one. And in addition, it's bonded to 1, 2, 3 other carbons. Because it's bonded to 3 other carbons, we call it tertiary. Now, you may see tertiary or secondary or primary written in the full word, or you may see it written as 1 and then a little degree, like degrees Celsius. You put, the little circle, or 2 and then the degree. That just means, that's just the short form for how you write primary, secondary, and tertiary. one last thing that's very important to note is tertiary is the maximum number. Now, why is this the case? There's no 1 with 4. I don't know how you even say that, but it doesn't exist. And the reason for this is because carbon can form a maximum of 4 bonds because it has 4 valence electrons. So one of the bonds is taken up because of the OH. That takes up 1 bond. Then we only have 3 left, and the 3 left are 3 other carbons. That would make it a tertiary. So that's the maximum. There's no other valence electron for it to bond to. So that's just one extra note for you. If you've enjoyed learning about alcohol at the molecular level, please subscribe down below. See you in the next video.